Hi friends, very good morning to all. Yes, today I am going to explaining about the next topic of Freshnel Biprism. Before going to start about that topic, what I discussed in previous class. So what is interference and types of interference? Before that, what is wavefront and types of wavefront? So their diagrams and also superposition principle and interference of light, that is phenomenon of redistribution of light energy due to superposition of two or more light waves. Due to two or more superimposed, what is the new resultant wave is formed, redistribution of light energy, that is the interference of light. There are two types, that is constructive interference and destructive in constructive interference, crust falls or trough falls, we get the result, that is a types of constructive destructive interference. Crust is falls on the trough or trough is falls on the crust. In that condition, it is a type of the destructive interference. You all of you, this topic I explained previous class. Next, coherent source and incoherent source. So coherence, same wavelength, same amplitude or a constant phase difference. Incoherent source, that is different wavelength and different phase differences. Okay, so Young double slit experiment. So it is one of the slit S1 and second, there is second slit that is having two holes. We getting the wavelets or wavefront are splitted into two and they are superimposed. We get the dark and bright fringes at the screen. So is one of the division of wavefront and division of amplitude. There are two types of the method to division. So this is the syllabus we know and introduction part. Share this screen. So next, the condition for sustained interference. So if you obtain the interference, what are the condition to make to obtain? So these are the five conditions. So already discussed. Now today class is Freshnel Biprism. So before going to start about Freshnel Biprism, so which scientific this one is described or discovered by Augustin Jean Fresnel. He was the French physicist who contributed significantly to establish the wave theory of light and optics. So Fresnel Biprism, this theory or this device described by Augustin Jean Fresnel. He gave a simple arrangement for production of interference of pattern. By help of this Fresnel Biprism, you obtain the interference. Due to interference, we get the bright and dark fringes. With help of this, we find out the width of the fringe width and also find out the monochromatic light wavelength of monochromatic light by help of sodium source. So Fresnel Biprism, who discovered and which scientist he is discovered? So what is the help of Fresnel Biprism? It gives the production of interference. With help of interference, we get the dark and bright fringes. Next, what is prism? All of you know prism is a transparent glass medium. It refracts when light is incident and it gives the deviation. When light travels from rarer to denser medium, automatically it will be deflected and angle of deviation will obtain. The angle of incident equal angle of emergent ray. It is not, this is it will change. That is prism. We can see in the slideshow. Prism is a wedge shaped transparent body which causes the incident light to separated by color. So when the light is passed, the different colors you observe different, having different wavelength. So separation by color occurs since the different colors corresponding to different wavelength. It is a device used to refract the light, reflect it or break it up. So dispersion, that is called as dispersion. Prism will main condition is it will disperse the light. It constitutes spectra colors. So next, prism shape. You all of know how the shape of the prism, how it is looking. So it having actually two triangle, three rectangles. One of the surface is rough. So it having one of the base. So one of the example, you already know that when the light is incident like that, it will not go straight, it will be refracted. Again, when it is rarer to denser one, it comes here. When denser one to rare, again it go to refracted here. So you can see the diagram. So they're making an angle here, angle of deviation. The first deviation is d1, again it deviation d2, so total deviation here. So these are our basic things you already know. So what is biprism? Actually, biprism is consisting of two prisms. They are kept in base to base. Look at here. It consisting of two thin acute angled prism joined at the bases. It constructed as a single prism of obtuse angle of 179 degree. The acute angle alpha on the both side is about 30 minutes. It means half degree. A portion of the incident light is refracted downwards and a portion is upward. So half of the portion is refracted in upward, half of the portion is refracted in downward. So we will see in next slide. So all of you see once again. So it is an prism, how it is look. So you take in this, like its angle here, it almost 179 degree, and remaining this angle and these remaining two angles should be half degree or 0.5 degree or 30 minutes. It means half degree, because 1 degree is equal to 60 minutes, half degree means 30 minutes. So remaining two angles half minutes or 30 minutes or half degree. Okay, so biprism, it consisting of two prisms, biprism, and they are kept base to base, because it is a one of the prism here, it is a one of the prism, it is a base, we kept another prism here, base to base they are close to each other. Okay, and forming a biprism. I will show next slide. Okay, see in this diagram. So this angle 179 degree, remaining half of degree. So how can kept this biprism with the source? So the prism is placed with the refracting edges are parallel. So refracting edges are parallel. Okay, refractings are parallel and to the line source. Yes, this is source. We can use a sodium source or light white light source, such that SA is a normal to the face of the prism. So this area is normal to the source. Next, how when the light is passing through the prism, when the see in the screen, this kind of bright and dark fringes are formed here. So how this will form, how this diagram will be obtained? So it is a source, this is a source I kept near the biprism. The source, yes, when this is a horizontal line I drawn, here is the screen. Okay, here is the screen. So in screen there is an eyepiece or a micrometer. So when the light is incident here, so for example light is incident like here, after it is refracted in this and reaches the screen, and some of the light is passing upper portion of the prism, and lower side also light is incident and refracted reaches the screen. So I make it this is extend this point, that is S1 is formed. This is a virtual image of the this source. S1 is a virtual image is formed when we are extended backward this point. Again here also same, when the light is when the this line refracted I extend it, and here is also S2 is formed. This is the virtual image source S2 formed with help of this main source S. So S1 and S2 are the virtual sources of same wavelength, same amplitude, so same phase difference, because the source is same. These two are the coherent source, so it acts as a coherent source. Look at the diagram. Once again I will show you that one. Here light is incident here, light is incident here, and refracted and extended. So and the light here where it is reaches, I extend this one here and extend the here also. So forming the bright and dark fringes when they are interface here. When the interface is there, they forming the dark and bright fringes in the screen. So you have to find out that fringe width by help of biprism. Next will they are the application. Why what is the use of this biprism? With help of biprism, we calculate the wavelength of monochromatic light. We can also find the fringe width of this wavelength or this sources. Next, so how the experiment is done? When a light is incident from the source, yes, on the lower portion of the prism, before one layer to lower portion of the prism, it bend upward. So automatically light is incident lower, it moves in upward, appears to come from the virtual source B. Here is the B and A, they are the two sources, S1 and S2. Similar light from S incident on the upper portion of the prism bent downward appear to come from A. So when the light is incident, refracted come to by B and upper portion, and again A point when the light is incident and refracted goes to A. So these are the two wavefront are formed with help of main source S. So S and B are the two virtual coherent source. AB is equal to D. Here is the AB. Here is the AB. That distance is D. Okay. Here is the small d. Next C is the screen. Distance between the source and eyepiece. So D is capital D. Look at here. You all of you know. D is the distance between the source and screen. Capital D. Okay, small d is the distance between the two sources, coherent sources. So interference fringes of the equal width will be occur between E and F. Here is the E. Here E and F. The equal bright and dark fringes are formed. The center line as shown here. Here is the phase difference is 0. The center line always obtain the bright fringes. So all of you know that one. Next portion of the screen, behind EF portion of the fringes of large width will be produced. After the long distance, automatically fringes will be produced larger. So next, since C is the equidistance from A and B, so that C is maximum. So look at C is the middle. C at the C is maximum fringe intensity will occur on both sides of the C. Alternate bright and dark fringes will be appear. According to previous theory, fringe width already with help of Young double slit experiment, this formula that we get that experiment. So look at the beta is the fringe width, lambda is the wavelength of light, d is the distance between the screen and the source, and small d is the distance between the slits. There are distance between the source S1 and S2, there is distance of small d. In that condition there are two slits are used, that is the source, so act as a source, that's why they are small d is. So with help of n, that is bright fringes, you have to obtain, you must this condition will be act as a like that, n lambda d divided by small d. N is the number of fringes and lambda wavelength. So if you obtain the dark fringes, just you multiply, that is 2n plus 1 into lambda into t divided by 2d. Just you multiply, upper side add 2 and lower side add or multiply 2. So is the dark. How can I multiply this one? We have to know about that one. Please refer Young double slit experiment. Here I will directly use this in this by Freshnel Biprism condition. Okay. Next, finally we get the wavelength. Lambda is equal to, I make it cross multiplication, lambda is equal to, so d goes to beta into d, so capital D goes down, so lambda is equal to beta d divided by capital D. So next, what are the application of biprism? What is the help of the Fresnel biprism? So determination of the wavelength of the monochromatic light. So with help of this Fresnel biprism, we can calculate the wavelength of the monochromatic light and determination of thickness of the thin sheet of the transparent material. So it is help to how much the thickness of the sheet we can find out. Determination of the interference fringes. So before only the interference pattern will be obtained, that is bright and that width we can also calculate. So this is a experimental apparatus arrangement. In practical, how they are done the experiment, how they are arrangement. You can see the slit and stands. Look at here, stand for wire, screen or eyepiece, slit. So these all are the practical arrangement. If we have an experiment, I will do this experiment. We get the result. Okay. Next is the main uh, topic of your syllabus, determination of wavelength by using light and the light, but we can practically use the sodium lamp by help of biprism, Fresnel biprism action. Next, in your books, first how to find out the fringe width. If you want to know about the fringe width, how can I do that one? That is when the fringes are observed in the field of view of the eyepiece, the vertical cross-section wire is made to coincide with the center of one of the bright fringes. The position of the eyepiece is read on the scale, say x0. So if you have to find out the fringe width, we have an eyepiece. Look at here in this diagram. I will show you. Here is the source, here is the biprism. How the biprism is look, it is a convex lens, it is the eyepiece. Look at it, here is the eyepiece consisting of field lens and eye lens. In the field lens, it is nearer to the object. Eye lens, it is very nearer to our eye. Okay. So I before going to, here is the in eyepiece, there is a cross wires, you will be there. You have to note that particular reading, you make it a cross wire on that particular dark or bright fringes. So look at here. So before you are noting that one, that is x0. After you move long last distance, that is xn. So look at that one. So micrometer screw of the eyepiece was moved slowly, and number of bright fringes, that is n, that pass across the cross wire is counted. Number of how many number of bright fringes you observed, you just counted in up to last end. That is the position of the cross wire is again read, so xn, that is the last point. The fringe width is then is given by. So how can I find out that fringe width? So there is a equation you have to write, that is last term, that is xn, and minus initial term first fringe width, that is x0, divided by total number of fringes you have to counted, we can get the fringe width. So how to find out source distance, that is two sources s1 s2, that distance is small d. You have to find out that these two source distance, you do this experiment. So a convex lens of short focal length, we choose a short focal length convex lens is placed between the slit and eyepieces. Before only I told that it is a convex lens. Look at the convex, how it looks, convex lens, you all of you know. So it is a convex lens placed in between the biprism or slit. Here is the slit, source slit, and it is a eyepiece. So such that it is very near to the biprism. So it is very near to the biprism. Okay. Next, then it move towards the eyepiece. It till the sharp pair of image of the slit is obtained in the field of view of the eyepiece. So when the it is very close to the biprism, up to how much distance we have to move, that we get the images, two pair of images formed at the eyepieces. So that much when we get, then only we stop the moving the distance of the eye lens, convex lens. So next, the distance between the image is measured, that is denoted by d1. So when the pair of images formed at the eyepieces, here is we can see the micrometer is have considering eyepiece. In eyepiece we get the images, so two pair of images form, that distance is small d1. Okay, and this distance we already know, the source distance is small d, and this is the object distance when the source and the lens distance between them is u, that is the object distance. And after the lens and eyepiece distance is image distance, that we can represent as a v. Okay, next after what we'll do that the lens is moved towards the nearer to the eyepieces, then we have to take the this distance is v, and this distance we denoted as a u. Again there is a pair of images formed, that distance between the pair of images d2, and this is the same distance is d. So look at that one. If u is the if u be the distance between the slits, and lens L1 and V be the distance between the eyepieces, and the lens L1, then the magnification, so all of you know what is the magnification, image distance divided by object distance, or image height divided by object height. So by help of that one, look at here, image distance, that is V, object distance, that is U, so V divided by U is equal to image size, that is d1, object height or size, that is d. So all of you know that what is magnification, linear magnification, angular magnification. Next, now the lens is moved to position nearer to the eyepiece, where again a pair of images of the slit is seen. So distance between the two sharp images again measured, let it be d2, again magnification is given by. So when the again there is a pair of images formed, that distance is d2. So in this condition, when the lens is moved towards the near of the eyepiece, in that time this distance is v and this distance is u. So automatically image distance, that is v divided by u, that is v divided by u is equal to d1. So sorry, here look at here, u, image distance u divided by object distance is v, is equal to image height divided by object height, that is d, always it is d. So d2, multiplying equation 3 and 4, both this equation and this equation just multiplied, automatically in left side they are get cancelled, because v divided by u, automatically u divided by v, automatically they are get cancelled. So remaining term is 1 is equal to d1 into d2, they are multiplied, d1 into d2 divided by d into d, that is d square. So I multiplied here, d1 into d2 divided by d square is equal to 1. So automatically this d square is goes here, so automatically d1 into d2. So I the squaring, I take it right side, automatically it will be making square root, that is square root of d1 into d2. So this is the expression. Next, finally using this value, that is d value and fringe width value. Okay, this fringe width value, that is distance between the slits or sources, and distance between the fringe width are kept in the previous equation, that is this equation. If we can help to find out the wavelength of monochromatic light. Okay, what we done this class is, what is Freshnel prism. With help of Freshnel prism, we calculate the wavelength of monochromatic light. So this is what is the help of Fresnel Biprism. It is mainly helpful for find out the fringe width and thickness of the sheet, and also help the calculate the monochromatic light. So what is Fresnel 5 prism? Please remember the how many lenses are, or how many prisms are used, and what are the angles, what are the interior angles. These all are keep it in your mind. Thank you for watching this video. I hope you are understand. I will also send you the animated video for how to take the reading for in this experiment. Thank you so much.